Hi guys, welcome back to Solid Design Principle series. In today's video, I will try to explain you interface segregation principle with the help of an example wherein we will see the violation of the principle followed by its fix. Okay, let's understand the definition first. Break big interfaces into smaller focused interfaces. So what does that mean? So say for example, you have an interface here which is comprising of maybe 10 different abstract methods. Okay, so it is very likely that all the implementations of this interface doesn't need all those 10 methods, right? It is very likely scenario that all the implementation might not need all those implementations. So that is why it is written here that it reinforces Liskov substitution principle and single responsibility principle. So if you have not seen my earlier video, I would suggest you go and have a look to LSP and SRP. I'll quickly explain. The reason it reinforces is because as per LSP, our derived class should be able to replace the base class, right? So if any of those implementation of this is empty, right? There is an empty implementation, so that means it is breaking Liskov substitution principle because we are forcing the concrete class to implement this I interface with an empty implementation. So that is why it is breaking the LSP, and possibly it could also be breaking the single responsibility principle because if all of this implementation of the interface, so say C1, C2, C3, doesn't need all these 10 methods, that means the responsibility is not properly aligned, right? There is more than one responsibility. Reason, it might be working on responsibility R1, right? And it might be depending upon the responsibility 2. That is why we have a different set of methods required by the class C3. So I have shown the collection interface here and the map interface here as an example, right? So as you can see here, the add method and the put method are segregated into separate interfaces instead of combining them into one so that they can play their own responsibilities. And one more thing I would like to cover here is at times we have a legacy code wherein we already have big interfaces. So how would you deal with them? So we will try to understand this with the help of an example. Alright guys, now let's try to understand interface segregation principle with the help of a very simple mathematical example. Let's create our package. Let's call it ISP. Now let's create a new interface. Let's call it shape. Okay, we want to calculate the area of a square for an example. Let's a method here public and get len and public and let's call it double get area. Okay, so we want to calculate the area of a square. Okay, so this is our initial interface for that. Now let's create the implementation class called square. Okay, which implements the shape interface. Okay, let's add the unimplemented methods. Let's create a property called len. Okay, and let's create a constructor which takes an integer argument called len. Let's assign it to this dot len equals to len. Alright, and then under the get method we will return the len, and in the area method we will return the length square. Okay, so that's our plain implementation of the shape interface as square. Alright, and let's create a new class called interface segregation test and add type name is not interface segregation. Oh, I'm sorry. Let's create the instance of our square. Square and pass 5 as an argument. Let's print out the length square length square dot get length, and let's also call the area method square dot get area. Okay, let's try to run this. So we are getting the length returned here as 5, which we are passing in here under the constructor, and the square area is also calculated. Now let's further extend this example, and now we want to implement it for a rectangle as well. So rectangle works on length as well as breadth. So we would need another method here called breadth. Okay, so as soon as we add the breadth here, the square starts to fail. So now we need to add the unimplemented method here, because we do not require the breadth for calculating the area of the square. We will have to live with the empty implementation here. Okay, so essentially we are breaking the Liskov substitution principle here. Okay, and now let's go ahead and implement the rectangle class. The rectangle class. Okay, and then let's pick it up from the square. And breadth. Let's fix this. Okay, so we have our length, we have our breadth method here. Okay, so this is going to return the breadth, and that's so this completes our implementation of the rectangle method. Okay, let's go back to our interface segregation test class, and similarly create an instance for rectangle now. Let's give it 10 as breadth. Okay, so what's the error? Cost to shape. Why? Okay, so this needs to implement the shape method, shape interface here. I'm sorry, I missed that. Okay, this should fix it now. Okay, so let's see. Let's call it rectangle. So we are simply replacing square with rectangle here. Okay, and then we can call the breadth here. All right, let's run it. So as you can see, our code runs fine. We are able to calculate the area for the square as well as for the rectangle. All right. So although this is already breaking the interface segregation principle here in this interface, because it is already fat enough to cause problems, because under square we have empty implementation here. Okay, now let's think of it as legacy code which was given to you. Okay, so this was already in this bad shape. Okay, so how would you deal with this? And now you as a developer has the responsibility to implement the area of a circle. So how would you deal with that? So if we go ahead and add get radius here, okay, which is not going to help but further pollute the code. So let's stop here and let's not add this property. Let's not add this method here, and let's think of something else. So let's try to create few more interfaces here. Okay. So let's call it as radius. Okay. So the job of this interface is to implement the get radius method. Okay. I'm sorry. So this is radius interface. Let's create another interface and let's call it the length interface. Okay. The job of this interface is to add the method called get length. All right. Similarly, we'll create one more interface. Let's call it breadth interface. Okay, and we will add a method called public int get breadth. So now you are seeing we are dividing that big interface called shape into different, more focused small interfaces. Okay, now let's create another interface called area. This will return this will be used to implement the area. All right. So let's first implement our new requirement and add a class called circle here. Okay, so circle is now going to implement the interface called radius and area. Okay, let's add the unimplemented methods here. Let's add radius here and radius. Okay, and let's let's add our circle constructor here. This is going to accept radius as input. Let's assign this dot radius equals to radius as an arg. And let's return the radius from here. Okay, so this is just for the sake of an example. This is a simple mathematical problem, right? Let's return the area here. Okay, easy. So this completes our implementation of the class circle now. So let's go ahead. So you can see we are not adding any unwanted methods here. We are only dependent upon the interface radius and area here. Okay. So let's go back to our class called interface segregation test and let's create an instance of circle. Let's give it a value 5 and print here radius of circle circle dot get radius. Likewise, we will print area of circle and let's call the method get area. Let's fix this in the area. Let's call it get area, similar to our initial shape class. Okay, let's fix this here. Get area and here as well. Get area. Okay, let's run it now. So we are able to calculate the area of circle now. So let's go back to our shape here. Okay, and let's comment all of these. Okay, and let's extend from the new interfaces which we have created. Okay, which is length, breadth, and area. Okay, so these methods will now be coming by extending the interface's length, breadth, and area. And we are no longer now dependent on the shape interface. So whatever is already implemented as a part of legacy code can stay here if required, right? This can stay here, or you can update it if you want. But as we are talking about legacy code, there could be hundreds of classes which are already dependent on that. So we will not touch upon them, right? But for our newer implementation, we have fixed the problem. We have started diluting our big interface into smaller ones, and now we are relying on them instead of the big interface. I hope this example helps you in understanding interface segregation principle. And if you liked it, please spread the word. Thank you.